Have you ever thought about how mountains were formed? Or the role glaciers play in sculpting the landscape? Perhaps you've observed a roaring river carrying dirt, silt, and even small stones. Or maybe you've been to the beach on a day when the surf was heavy and waves ate away at the shoreline. Maybe you've seen sand blowing through the air. Where did it come from, and where will it end up? During the next few minutes, we're going to explore these questions and many others as we investigate many of the forces involved in shaping our Earth. This view of the Grand Canyon seems rather fixed and still, but viewed in terms of geologic time over many years, the landscape is anything but. It's in a constant state of movement, even though these movements cannot be seen at the moment. For example, the rocks high atop this canyon wall were once deposited at the bottom of ancient seas, and the tops of these mountains were once below sea level. What forces caused them to be thrust upward? Within the Earth are forces that push and pull on the crust. These forces are collectively referred to as stress. When enough stress is placed on the material in the crust, it can move and change shape. There are several different types of stress within the Earth. One type of stress is called tension. Notice how when this piece of gum is stretched out, it thins in the middle. Rocks under tension can be stretched as well. You decide. What would happen to this piece of candy if you were to push on it from both ends? That's right, it would buckle in the middle. Compression is the process of squeezing rocks in the crust, which often makes rocks denser. Compression also may push rocks higher or lower. Rocks in the crust often undergo a process called shearing, during which rocks are twisted or torn apart. Let's take a look at some of the ways stress affects the formation of the Earth's topography. A quick look at a global topographic map reveals bands of mountains referred to as mountain belts. A large belt of mountains can be seen going all the way down the western flank of North America, through Central America, and along the western edge of South America. Most mountain belts show evidence of crustal movement, including folding and faulting. Folding is the process of rocks in the crust bending. The Appalachian Mountains were primarily formed by folding. The process created many valleys and ridges, as seen in this satellite image of Pennsylvania. The two most common types of folds are anticlines and synclines. An anticline is created by arching or upfolding rock layers, whereas synclines are down folds of rock layers. Many mountain ranges consist of a series of anticlines and synclines. Keep in mind, however, that this is a very simplified view of a very complex process. When stress is applied to this frozen candy bar, it breaks instead of bends. This can also occur with layers of rock. Faulting is the process by which rock layers break when placed under stress. You decide. What is a fault? A fault is a crack or break along which rocks move. Rock layers on both sides of the fault have the potential to move in either direction. The region above a fault is called the hanging wall, and the region below a fault is called the footwall. When forces of stress cause the hanging wall to move down relative to the footwall, a normal fault is formed. Quite often, normal faults are steeply inclined and may form cliffs or fault block mountains. In turn, valleys, such as Death Valley seen here, may form when the area between normal faults slides downward. Forces of compression play a role in the formation of another type of fault. If the hanging wall moves up in relation to the footwall, a reverse fault is formed. And when the hanging wall moves up and over the footwall, thrust faults are formed. Thrust faults are common in mountain ranges where intense folding is found. When rock layers slide past each other side by side, a type of fault called a strike-slip fault is formed. The San Andreas Fault in California is a type of strike-slip fault. How did these large rocks get here? They fell from the cliff above, pulled down by the force of gravity. Mass wasting, or mass movement, is the process of gravity causing sediment and other debris to move downhill. Sometimes this process is quite rapid, as in the case of a landslide or rock slide. Landslides range in size from relatively small hillsides to large areas of entire mountains. They have the ability to cause tremendous destruction, and in some areas are a major threat to life and property. Mud flows consist of the mass movement of mud, dirt, rocks, and waste moving downhill. These can cause catastrophic damage as well. In Iceland in 1996, a huge mass wasting event occurred when a volcano erupted under a glacier and rapidly melted it. A large lake was formed, which eventually burst, sending water, mud, ice, and rock downhill. It wiped out everything in its path, leaving this huge debris field. This is all that remains of a bridge mangled by the torrent. At other times, earth materials move downhill quite slowly in a process called creep. This beautiful mountain stream has been gradually carrying particles of rock off the mountain for hundreds of years. The Colorado River, here at the bottom of the Grand Canyon, has been eroding this deep canyon for thousands of years. Erosion is the process by which particles, which we call sediment, are moved from one place to another. You decide. What's the biggest cause of erosion? Moving water plays a big role in the process of erosion, carrying huge amounts of sediment. When rain falls on the land, water does not always flow into the earth, but may flow across the surface. Surface runoff refers to water that flows across the surface of the earth. When water moves across the surface, it has the potential to carry sediments with it. Areas with steep slopes and little vegetation are most prone to surface runoff, while areas with lots of plant life experience much less soil erosion. Streams and rivers also have the potential to shape Earth's surface. Moving bodies of water play a big role in the process of erosion, carrying huge amounts of sediment. A glass full of water from a large, fast river reveals it's full of sediment. Some fast-moving creeks and rivers are even capable of moving large boulders. These moving bodies of water are also capable of eroding stream banks in a process referred to as stream erosion. Over long periods of time, rivers wear down the land over which they flow, forming deep valleys or canyons. Even the fastest moving bodies of water eventually get to a place where they slow down. As water slows down, sediment settles to the bottom in a process called deposition. Deposition is the process by which sediment is laid down or settles in a different place. The sediments from this stream bottom were transported from somewhere upstream and deposited here. Quite often, sediments are deposited on the inside bend of a river or stream, where the current is not as strong. As a river runs off a steep mountain onto flatter terrain, its speed decreases and sediment is deposited. When this occurs, sediment builds up, forming a structure called an alluvial fan. This alluvial fan in Nevada was formed over many years when intermittent streams flowed down the mountain and deposited sediment where it settled in the flat valley floor. Deltas are formed when large amounts of sediment are dropped when a stream or river enters a lake or sea. The Nile River Delta, for example, was formed when sediments were deposited in the Mediterranean Sea. This satellite image shows the Mississippi Delta in Louisiana, where the Mississippi River drops sediments at its mouth in the Gulf of Mexico. Waves have the potential to cause erosion on the shorelines of lakes and oceans, and they can cause damage to shoreline property. Waves weather rocks on the shoreline into smaller and smaller pieces that are eventually carried away. Powerful waves can also shape the shoreline. Along the beaches like this one in Cape Cod, Massachusetts, storms produce large waves which can carry significant portions of beach sand and sea. Beach erosion is the process by which sand and other materials are carried away by wind and waves. These forces can cause beaches and even sea cliffs to erode. In some cases, large columns called sea stacks are formed when less resistant rock is eroded around more resistant pillars. Sea caves may be formed as less resistant rock is hollowed out of a cliff. Waves also deposit sediment. For example, eroded particles deposited on the shore form beaches. The type of sand found on a beach depends on the type of rock from which the sediment originated. You decide. Where did this black sand come from? The black sand on this Icelandic beach originally came from volcanic rock, and this sand on a beach in Maine originated from granite rocks. Waves and currents may deposit long ridges of sand called sandbars, and spits are found when sandbars are connected to the shoreline. Have you ever been in a strong wind that whipped stinging sand against your face? If you have, you know that wind is a powerful agent of erosion. Where soil is exposed to the surface, such as in the desert or on beaches, wind erosion can be a powerful force, carrying away particles of dust and sand. In the 1930s, wind erosion devastated states such as Oklahoma and Kansas, where it swept away soils, turning the region into a dust bowl. When wind speed decreases, particles are deposited. Desert sand dunes are formed when wind deposits sand. Dunes are also commonly found along large lakes or oceans. Sand dunes are constantly changing shape and moving as wind erodes them and deposits sand elsewhere. You decide. Where did these icebergs come from? These icebergs broke off a glacier that can be seen in the background. A glacier is a large mass of ice and snow that moves. Glaciers shape much of the landscape in Canada and the northern United States. They have the ability to move large rocks and massive amounts of the earth. There are two major types of glaciers. Continental glaciers, like those found in Greenland and Antarctica, cover large polar regions, whereas valley glaciers, located in high mountain valleys, are much smaller. When snow and ice accumulate at a greater rate than they melt, glaciers are formed. Gravity pulls the mass of snow and ice downhill. As glaciers move across the landscape, they erode it, acting like a giant bulldozer, lifting and pushing surface materials. Notice how dirty this glacier is, evidence of earth materials transported by the glacier. Valley glaciers characteristically form U-shaped valleys, as seen here in Yosemite Valley in California. While glaciers have the ability to sculpt mountains and lakes, they also deposit many features. This jumble of rocks and boulders, called till, was deposited from a glacier. This long ridge of till, deposited at the base of a glacier, is called a moraine. Moraines may also form along the sides of glaciers. This stream is called a meltwater stream and originates from the glacier behind it. This dirty-looking water contains sediments from the glacier, which are often deposited on flatter areas called outwash plains. And this small pond, called a kettle pond, was formed when a block of ice lodged in till melted, leaving a water-filled depression. These are just a few of the ways glaciers erode and shape the landscape. During the past few minutes, we've taken a look at some of the fascinating ways the surface of the Earth is shaped. We discussed how the crust moves and examined forces within the crust, such as tension and compression. The geological processes of folding and faulting were explored. Some of the different aspects of mass movement were discussed. Different agents of erosion were described, including that of moving water, wind, waves, and glaciers. In turn, the concept of deposition was explored, and examples of different features created by deposition were provided. So, the next time you admire a mountain range, see a roaring river, or witness sand whipped by the wind, think about some of the things we've discussed in the past few minutes. You might just look at the surface of the Earth a little differently. Fill in the correct word to complete the sentence. Good luck, and let's get started. Number 1 involves pushing and pulling within the Earth. Number 2 is the process of rocks bending. Number 3, and is created by upfolding rock layers. Number 4, A is a crack along which rocks move. Number 5, mass is the downhill movement of earth materials. Number 6. Moving water is a major agent of Number 7. Refers to water flowing across the surface. Number 8. Are the result of sand deposited by wind. Number 9. Are moving bodies of snow and ice. And number 10. A ridge deposited at the base of a glacier is a